Now I will discuss with you a new topic of the chapter number system. This is to be considered as the exponents of the real numbers. In fact, a lot of discussion in my previous lecture has been taken place about the real numbers, that numbers may be rational or may be irrational are considered to be the real numbers. Now, in order to explain you what are the exponents, what are the powers, what are the base, I am taking few examples, and the total exponents will be discussed only and only about the real numbers. No imaginary number will be taken for discussion in this chapter. Question is, what is exponent? In case if a student want to multiply any real number, suppose a 3 times. So writing a into a into a, it is the expanded notation. One can say it is power 1, power 1, power 1. So when power 1, power 1, power 1 is clubbed, it can be written as a is to power 3, or we say a cube. So a is the base, 3 is the exponent, and a cube is the power. So what is the exponent? If there is a base, suppose 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5. So base is 2 and its exponent is 5, and this is known as 2 raised to the power 5. So this kind of discussion will take place in the chapter exponent of real numbers. As I want to explain you few problems also, so before it, what are their rules? So what are the rules? If the base, suppose I am taking the first rule here, if the base of two exponents is same, let us suppose the base is 2, or you can change it, you can write, suppose a is to power m and another is a raised to the power n. I am multiplying a is to power m into a is to power n. The base of both is same. That's why powers are different. So I will say in this problem of exponent, a is to power m plus n. So when bases are same, powers are different, then in the product, the answer is same base and sum of the powers m plus n become a is to power m plus n. This is the first. Suppose I talk about that bases are same and powers are different and the operation is of division. In case of the division operation, the result will be a is to power m minus n. Second. The third is, if operation is like this, a is to power m, then power n, a is to power m, then power n. That's why we say powers raised to the power power. This becomes a is to power m into n. So, if the bases are same, powers are different, operation is product, answer is same base and sum of all powers. It is not mandatory that we will block it only on the two products. There may be a is to power m into a is to power n into a is to power p. Then answer will be a is to power m plus n plus p. In the division, powers needs to be subtracted. In the exponent, like this, a is to power m raised to the power n, answer is a is to power m into n. Now, if I say the bases are different, like a is to power m and b is to power n, and bases are different, powers are same, we call it a into b whole raised to the power n. Now, the next we can say, if it is a is to power m divided by same power, different base, answer will be a upon b raised to the power m. So these are the 5 basic rules which we will operate. With the help of this, I also want to tell you there may be another rule. In case somewhere if it is written like nth root of a. Nth root of a means a raised to the power 1 upon n. This becomes the answer of nth root of a. Suppose it is written that nth root of a raised to the power m. So in case of nth root of a raised to the power m, answer will be a raised to the power m upon n. In case the question is like nth root of, then mth root of, suppose it is what? First nth root, then mth root of b. So we can say it is nth root of b raised to the power 1 upon m. That is why first I have operated this one. Then I can say b raised to the power 1 upon m, that raised to the power 1 upon n. In this, if I apply the powers to power 5, this rule, if I apply this rule here, I will find answer as b raised to the power 1 upon mn. And in the notation I can write mnth root of b is the answer or simplified value of this. So we will see that which rule is applicable, and according to the required rules we will solve the problem. Now I want to discuss a basic example based upon the exponents. If a is equals to 2, value of a is 2, value of b is to be taken as 3, then find the value of the first part a is to power b plus b is to power a, and second 1 upon a plus 1 upon b whole raised to the power a into b. So for first part, a is to power b, what is a? 2. I am writing here question again, a is to power b plus b is to power a become 2 is to power 3 plus 3 is to power 2. 2 is to power 3 meaning by 8 and 3 is to power 2 meaning by 9. Answer is coming out to be 17. This is about the first part. If I tell you about the second part, for getting the answer of second part, 1 upon a plus 1 upon b, that whole raised to the power a into b, I can say it is 1 upon a means 1 upon 2, 1 upon b means 1 upon 3, whole raised to the power a into b means 2 into 3. Answer of 1 by 2 plus 1 by 3 become 5 by 6, and that's to the power 6. 5 by 6 raised to the power 6 is the answer of our 1 upon a plus 1 upon b whole raised to the power a cross b. 5 by 6 raised to the power 6 can be simplified by writing 5 into 5 into 5 into 5, 1, 2, 3, 4 into 5 upon 6 upon 6 upon 6 into 6. 1, 2, 3, 4, then 6. So the simplification of this part will give you the answer. Now I am taking one more example based upon the exponents and power of the real numbers. It is like simplify 81 upon 16 raised to the power minus 3 by 4 multiplied by 25 by 9 raised to the power minus 3 by 2 divided by 5 by 2 is to power minus 3. So how we will simplify it? It is 81 upon 16 raised to the power minus 3 by 4 multiplied by big bracket 25 upon 9, that's to the power minus 3 by 2. If I operate or change this division, in place of this I can write multiplied, but this base 5 by 2 will reverse. So after reversing 5 by 2, this will be what? 2 by 5, no change in the power minus 3. So in first step, I just have changed this divide as product by swapping or reversing the base in front of this division. Now 81, prime factorization of 81, and this is 16, but this is negative power. You know it, when the negative power you want to make positive, what we need to do? We just need to reverse what? We need to reverse the base. So this can be written as, first of all you can write this part as 3 to the power 4, because 81 means 3 to the power 4, 16 means 2 is to the power 4, and that's to the power minus 3 by 4. Multiplied by, this is 25 by 9. This is 5 is to the power 2 upon 3 is to the power 2 and whole raised to the power minus 3 upon 2. Multiplied by 2 by 5, or I can say 5 by 2 raised to the power 3, because it is negative power. I have changed these negative to positive. So base 2 by 5 changed to 5 by 2 and bracket close. Now as per the rule, 3 and 2 are the different bases but powers are same. So I can write it as 3 by 2 raised to the power 4, and that's to the power what? Minus 3 by 4. Multiplied by, this becomes 5 by 3 raised to the power 2, because 5 and 3 are different bases having the same power, and that's to the power what? Minus 3 by 2, multiplied by 5 by 2 raised to the power 3. Now I can say 3 by 2 and its raised to the power 4 multiplied by minus 3 by 4 into, this become 5 by 3 and that's to the power what? 2 into minus 3 by 2 multiplied by what? 5 by 2 whole raised to the power 3. This becomes, now the question is, 4 and 4 get cancelled, 2 and 2 get cancelled. So I have 3 by 2 to the power minus 3 into 5 by 3 to the power minus 3 into 5 by 2 to the power 3. Now if I change this negative, I will change it like this, 2 by 3 to the power 3, because base is reversed, then power negative become positive, multiplied by 5 by 3 is to power minus 3 can be written as 3 by 5 is to power plus 3. Same, if minus is reversed here, it will become plus, and 5 by 3 change to 3 by 5, multiplied by 5 by 2 to the power 3. Now I will expand it. So I am going to show you result here. How? This becomes 2 by 3 once, then 2 by 3 twice, then 2 by 3, or in simplified form you can say 2 by 3 cube means 8 by 27. That is 2, 2, 2, 3 times multiplication 8, 3, 3, 3, it is 27. Multiplied by 3 cube, it is 27, 3, 3, 3, 5, 5, 5. This becomes what? 125. Multiplied by 5 cube, 125 divided by 8, because 2 cube is this. 27 cancelled with 27, 8 with 8, 125 with 125. So net answer of this long question is coming as what? 1. So simplification of this entire is what? Answer is 1. Now one more example of the same topic. This is simplify 16 into 2 raised to the power 9 n plus 1 minus, this is 16 into 2 raised to the power n plus 1 minus 4 into 2 raised to the power n whole divided by 16 multiplied 2 raised to the power n plus 2 minus 2 into 2 raised to the power n plus 2. So first of all, I want to tell you that this entire question can be converted in the form of base 2 and having some power. This 16 can be written as 2 raised to the power 4. It is 2 raised to the power 4 into 2 raised to the power n plus 1. 4 can be written as 2 raised to the power 2 into 2 raised to the power n divided by 2 raised to the power 4 into 2 raised to the power n plus 2 minus 2 into 2 raised to the power n plus 2. Now as bases are same, so what we can say, this becomes 2 raised to the power n plus 5. Here powers are 4, it is n plus 1, same base, multiplication, powers are added, n plus 1 plus 4 become n plus 5 minus. This becomes 2 raised to the power n plus 2 with same reason. Divided by, this becomes 2 raised to the power what? 4 and n plus 2 become n plus 6 minus 2 raised to the power, this is 1 power, n plus 2, this become n plus 3. Now the question is, in order to simplify, this can also be written as 2 raised to the power n plus 5 can be written as 2 raised to the power n into 2 raised to the power 5. I have separated the variable and constant in the same power separately, same base, reverse of it. If when product is there, power can be added, or on the same base, if two different powers are there, so they can be written in the expanded form like this. Minus 2 raised to the power n plus 2 can be written as 2 is to power n into 2 is to power 2 divided by. Similarly, 2 is to power n plus 6 is 2 raised to the power n into 2 raised to the power 6 minus 2 raised to the power n into 2 raised to the power 3. I can say 2 raised to the power n is common. So this becomes 2 raised to the power n. Left is 2 raised to the power 5 minus 2 raised to the power 2 divided by, I am taking variable power common, that is 2 raised to the power n. I left with 2 raised to the power 6 minus 2 raised to the power 3. 2 raised to the power n and 2 raised to the power n get cancelled. 2 raised to the power 5 is what? 32 minus 2 raised to the power 2 is what? 4 upon 2 raised to the power 6, 64 minus 8. Now if I subtract 4 from 32, it is 28. And if I subtract 8 from 64, then 14 minus this becomes 6 and it is 5. 28 upon 56, its simplest form is 1 by 2. So this total value is resulted as what? Half. This is the simplification. Some similar problems I will also share with you where level of difficulty will be much more. Now I want to share with you one more important question which is purely based on the rules of exponents. What is the question? Please see. If 9 is to power n, this is 9, that's to power n, multiplied 3 square multiplied by 3 is to power minus n by 2 is to power minus 2 minus 27 raised to the power n, entire divided by 3 is to power 3m into 2 cube is equals to 1 upon 27. If this value is equals to this value, then prove that m minus n is 1. Or you can say this condition holds true only if m minus n is what? 1. In order to prove it, we will apply the rules, we will follow the step, we will solve the question very properly and systematically. First of all, I want to see that this base is 9. 9 is composite number, so it can be written as the product of two or more prime numbers. What are two numbers whose product is 9? It is 3 into 3. So this becomes 3 into 3, that's to the power n, into 3 square into, this is what? 3 is to power minus n by 2 into minus 2. Because power is to power, then base will remain same and powers will be multiplied. Minus 27 can be written as 3 cube and that's to the power n Same 27 is composite, can be written as 3 into 3 into 3, which I can write 3 cube. This divided by 3 is to power what? This is 3m and this is what? 3. So I can say this is 3 is to power 3m plus, but base is different, so I cannot add. This will remain 3 is to power 3m into 2 cube. This is into 2 cube. And this result is running is equals to 1 upon 27, or this 27 can also be written as 3 cube. Never mind, we can change in the next step. Now this process is coming like this, that is, this become what? 3 is to power n into 3 is to power n into 3 is to power 2 minus. This minus and minus become positive and 2 get cancelled. So what become this? This become 3 is to power n minus powers to the power. So these 3 and n will multiply. So this becomes 3 is to power 3n divided by 3 is to power 3m into 2 cube is equals to 1 upon, we can say, 3 cube. What? Because 27 can be written as 3 cube. Now here what we can say, in the numerator we are finding this is, by chance I have written here minus, this is a sign of product. So this is 3 is to power n, 3 is to power n, 3 is to power n into 3 is to power 2. This first term can be written as 3 is to power 3n into 3 is to power 2, because 1n and 1n become 3n, base is same, powers are added and I left into 3 square as it is, minus 3 is to power 3n divided by 3 is to power 3m into 2 cube is equals to 1 upon, what can I say now? 3 is to power 3n is common, so this becomes 3 is to power 3n. If it is common, 3 is to power 3n in the numerator, nothing is written with the second term, so I can write the multiplicative identity 1, because 1 is such number which multiplied with any number does not make any effect in the result. So in this term 3 is to power 3n, if nothing is multiplied, I have written here 1. 3 is to power n is common, then what left? 3 square minus 1 divided by 3 is to power 3m into what? 2 cube. 3 is to power 2 minus 1 upon 2 cube, and this result is equals to 1 by 3 cube. I can say 3 is to power 3n and 3 is to power, this is n and this is m. So we cannot cancel. This becomes 3 is to power what? 3n. Now 3 is to power 2 minus 1, this result is 8, because 9 minus 1 is 8 and 2 cube is 8. So these two get cancelled. I left with what? I left with 3 is to power 3n upon 3 is to power 3m is equals to 1 upon 3 cube. Now as bases are same, so I can say this becomes 3 is to power 3n minus 3m is equals to 3 is to power what? Minus 3, because this is in the base. So 3 is to power 3 when come up, then it can be written as, when this value comes from denominator to numerator, it is this. Now if I compare the left hand side and right hand side, I find their bases are same. So I can say this implies 3n minus 3m is equals to minus 3. The power in the left side of the base 3 is 3n minus 3m, and power in the right hand side base 3 is minus 3. Now here if I want to change this sign, I need to change the sign of the entire equation. So on changing, this will become negative, this will become positive, this will become positive. So this becomes 3m minus 3n is equal to 3. Now 3 is common. So if 3 is common, I left with m minus n is equal to 3. This 3 will cancel this 3 and quotient will be 1, remainder will be 0. So answer of m minus n is 3 upon 3, that is what? 1. This is something what we actually need to show, that m minus n is 1, and here also we are getting m minus n 3 upon 3, that is what? 1. So these two values you can match and can say with the help of exponent. There are certain number of results can be proved also, bases can be compared also, and powers are added in case of product, subtracted, same base in case of division. Can be powers be multiplied in case when the base is 1 and powers to the power is there. Now I am taking another example which is purely based upon the rules of exponent. This is prove that a raised to the power minus 1 divided by a raised to the power minus 1 plus b raised to the power minus 1 plus a raised to the power minus 1 divided by a raised to the power minus 1 minus b raised to the power minus 1 is equals to 2b square upon b square minus a square. In order to prove this, first I am simplifying the first part. What is the answer of a raised to the power minus 1 upon a raised to the power minus 1 plus b raised to the power minus 1? I am taking first this part. A raised to the power minus 1, as I am removing the negative power, I can write it as 1 upon a. Then a raised to the power minus 1 become 1 upon a plus b raised to the power minus 1 become 1 upon b. So this part is like this, 1 upon a divided by, here the LCM is what? AB, this become b plus a. Now this part in denominator which divides 1 upon a can be written as 1 upon a multiplied by ab upon b plus a. So here when a and a get cancelled, we have obtained this is b upon b plus a. b upon b plus a is the simplified form of the first term of the expression. Now I am taking second term. The second term is a is to power minus 1 divided by a is to power minus 1 minus b is to power minus 1. This can be written as a is to power minus 1 is written as 1 upon a divided by 1 upon a minus 1 upon b, can be written as 1 upon a divided by ab as LCM, and the answer here will be b minus a, which can be written as 1 upon a multiplied by this denominator's reciprocal, that is ab upon b minus a. Here a and a get cancelled. What left? b upon b minus a. This is the simplified form of the second term. This is the simplified form of first term. This is of second term. Sign in between these two is positive. So now I want to add this and this. So this become, first is b upon b plus a plus second is b upon b minus a. Their LCM become b plus a into b minus a. This become b into b minus a plus b into b plus a. This is coming out to be b into b as b square minus ba plus b square plus ba. I have written here ab and ba having same meaning. b plus a, b minus a identity is b square minus a square. Here clearly this ab and ab, negative and positive, get cancelled. The left is b square plus b square, 2b square, divided by b square minus a square, that is denominator. This is the required result which we want to prove. You can see my both the fingers, and I am indicating here that what we want to prove has come out. So you can apply these rules to solve any number of questions to make your math more powerful, energetic, and you will find something